Hi there. In this video, we are going to be studying place value in whole numbers. And that is a math skill. So I'm going to turn to the math section of my notebook. If you don't have a notebook, that's perfectly fine. Whatever you're using to write on is just fine. But I have set up a digital notebook so that I can show you the information I need to show you. And I have a blank sheet of paper. That's what you want for this lesson. But I also need you to find some flashcards. So that's what these two boxes are. If you have the flashcards in the packet that we hand out with this course, you can locate those. If you don't have the packet and you want to just make yourself some flashcards, that's fine too. Index cards work very well. But the first thing I want to do is give this page a title so that if I am looking back through my notes, I know what the name of the skill is that we're studying. This is a very important skill in math. Place value in whole numbers. We are not going to talk about the decimal place values in this lesson. Those will come a little bit later in our studies. So the two flashcards you need, and I want you to know if you hear paper shuffling in the background, those are just my lesson notes. I'm not using a textbook. I'm using notes that I've made. So I'm not holding out on you. I'm just keeping myself on track. You need the place value that has the word, the flashcard that has the word digit, and the flashcard that has the phrase place value. So this lesson has two vocabulary terms, and I want to take just a minute to talk to you about the importance of vocabulary in math. I won't say most, I'll say all branches of science have their own vocabulary. And to be really good and comfortable with those subjects, you need to be able to speak the language. Math is no different. There is a math language that you really need to know in order to be able to understand math at a higher level. One of the things that students struggle with most in my experience is the math vocabulary. So I'm trying to work that in as we go through these lessons and help you build that language of math. So on the back of the digit card, I'm going to make myself a back on this one. Let's put the definition of digits. What is the meaning of digit? And it's really a picture. Digits are 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. And you may be thinking, well, what about 10? 10 is a combination of digits. It's a 1 and a 0 that is needed to make a 10. If you want to make a 25, you need a 2 and a 5. And so we have 10 digits to work with, counting 0. And the position of those digits in a number changes the value. So let me just tell you a little bit about digit and numbers. I've had students say, oh, so a digit is just a number. It is, but it isn't. If you think about the number 25, that's a number. 25 is a number. How many digits does it have? It has 2. So it is a number with 2 digits. So as long as you're talking about the numbers 0 through 9, you can use digit and number interchangeably. But once you get into 2-digit numbers or 3-digit numbers, the term digit and number do not mean exactly the same thing. Okay, place value. And that's what we're studying in this lesson. So on the back of your place value card, here is the definition. Place value is the value of a digit based on its position in a number. And I will show you an example. Let's take the digit 5 and let it stand alone. And then let's take the digit 5 and put it with 2 zeros. The 5 is the same digit. I draw a 5 exactly the same way every time. But are those two 5s worth the same amount? If you're talking about money, which of these values would you rather have? I would rather have the 500. So in the 500, the digit 5 has a greater value. And that's what we're talking about here. We are talking about the value of a number, the value of a digit. Let me get my terms right. Based on its position in a number. And we are going to spend our entire lesson working on that. So if that's not making much sense right now, just bear with me for a little while and it should get a little better. So now that we know the key terms for this lesson, let's look at the memory piece. If you have the packet of materials, this is item 1 in the memory piece. It is a chart of the place values. So go ahead and find that piece. If you want to go ahead and stick it down onto your notebook, that's fine. Or if you want to wait and do that later, that's fine also. Now I'm going to color code mine. You don't have to do that, but if you have colored pencils or highlighters, those really help me to see things in different colors. So the first thing I'm going to color in is my what I call the punctuation. So let's take this first piece, and I'm going to have to zoom in a little bit. I'm going to color this decimal point section in yellow. And I'm very much working with coffee in my system, so I'm a little shaky today. Here is the decimal point. Now in most numbers, whole numbers, you are not going to see the decimal point. It's there, but you don't see it unless you have numbers after it. We have a comma here. Notice that comma in this section. And then we have a comma in this section. So after every 3 digits in a number, you put a comma. The comma separates sections, or periods, it's called in math, of 3 digits. So those are the punctuation pieces. And let's just put some notes in here about the decimal and the commas. What does a decimal point do? A decimal separates the whole values from parts. So let's suppose that I'm buying a taco and it costs $1.25. The decimal in that $1.25 separates the whole dollar bills from the coins. It separates the whole from the fractions, the parts. and a decimal can only appear once in a number. Only one decimal per number. Okay. I'm going to change my pen size just a little bit. That's very hard to read, so I'll make it easier to read. So what about the commas? Commas separate math sections. And are used every 3 places. So you can have many commas in a number, but only one decimal. So let's study our place value chart for just a second. The first section I see is called the units section. So I have 1, 10, and 100. And I think I'm going to color this too. I did in my notes, so I want to keep this the same as the notes I'm looking at, or I will get all confused. So I'm going to shade in here in orange. So we have the unit section. Now I want you to notice there is a pattern here. The ones, tens, and hundreds always fall in the same order. The ones will be on the right, the tens will be in the middle, and the hundreds will be on the left in every section. So you need to look at that pattern and sort of commit that to memory. Ones, tens, hundreds. Okay. And then we have the thousand section. So we put the comma in, we move over and start our thousands section. So we have 1,000, 10,000, 100,000. And I colored this with green. Let me not make it quite so dark. I don't want to obscure the words. Let's see if we can do this a little faster. So hundreds on the left, 10 in the middle, 1,000 is on the right. That 1, 10, 100 pattern repeats itself through every single section. All I'm changing is the name of the section. So if we're in the thousand section, we say 1,000, 10,000, 100,000, and then we're moving to a new section. And this one is the millions section. So let's name our section. And then we have 1 million, 10 million, 100 million. That pattern is so very important. It just repeats itself over and over again. So let me quickly color this in. And I'll show you how this chart works. I wish I could make an interactive chart where you could just keep changing this out. But let's say that I put in you don't have to do this because if you can't erase, you don't want to mess your chart up. But a 5 in this seat is worth more, way more, than a 5 in this seat. So you see how I'm putting the 5s in there, in the tens or the 10,000. It's the same digit, but by changing its place in the number, I'm changing its value in the number. And that's what this lesson is really about. Understanding the places and the values that are associated with those. And here's one more piece of information. Each place, and I'm back on that big old pencil again. Each place is 10 times the value of the place to its right and 1/10 of the value of the place on its left. So another way to think about that statement is this. If I am moving to the right, numbers are getting smaller. If I am moving to the left in my place value chart, numbers are getting larger. And we're talking about place values here, not a number line. So if you're moving up in the place value chart, moving to the left, the numbers are getting larger. If you're moving down in the place value chart, the numbers get smaller and smaller and smaller. And our number system is based on tens. So we either multiply by 10 or divide by 10 to move up and down in the chart. Okay, let's look at another set of vocabulary words. I almost made flashcards for these, but I think they're going to help you much more if you see them written together. So let's make a space for these. These are called forms of numbers. And there are 4 basic ones that we can use in math. I'm not going to talk about one of them today. I'll tell you what it is, but we're not going to go that far yet. We're not quite there. First form I want you to know about is standard form. So in standard form, you use digits and commas to make your number. So let's say 6, 2, 5, 4. That is a number in standard form. Expanded form. This is a number form that shows the place values. So I have 6 thousandths, 2 hundredths, 5 in the tens place, and 4 in the ones place. 6,254. So if I were to write that in this place value chart that I just drew, I would have 6,000. Let me make that even a little darker. 6,254. And that helps me do my expanded form. 6,200, 5 tens, 4 ones. And then the third one that we can use today is word form. I always hated this one when I had to write these in school because I had to spell everything out. But we have 6,000, there's a comma between thousands and hundreds, 254. The other form that I'm not going to go into today is called scientific form. And you'll get that a little later on. But for today, let's just stick with our basic stuff on place value. I want to give you some test examples related to place value, and then we will take a look at the practice for this lesson. Your book has a whole set of practice questions, so we'll look at those too. But let's do a couple of examples. So I'm going to turn to my next page and write this example, and I need you to write it with me. If you need to stop your video, that is fine. How does the 9 in 96,532 compare to the 9 in 59,623 ? Alright, so we are comparing the value of the digit 9 in two different numbers. So let me highlight the 9s so we can see really what we're looking at. We're comparing this 9 to this 9. So let's write these numbers down. We have 96,532, and the 9 in this number is in the 10,000s place. So I'm just going to write the 10,000s place name down here. If you count these off, you start at your 2 and you would have ones, tens, hundreds, comma, thousands, 10,000s. So 9 in the 10,000s place is 9 with 4 zeros. That is 90,000. 9 10,000s. And then in this number we have a 9 in the 1,000s place. So our 9 is sitting one place to the right of that first 9. So this is 9 in the thousands place. And that would be 9,000. So I have just written the value of each of those 9s. And then to answer this question, we need to divide our two numbers. So don't panic on me here. I'm going to show you a shortcut. Here's 90,000. And we're going to bring the 9,000 right under here. Okay. So here's 9, 1, 2, 3. So I'm just setting up a division problem. Now you could put that in your calculator. You could say 90,000 divided by 9,000. But let me show you a mental math strategy that you can use here. So let's zoom in so that we're just looking at our problem. We're going to cancel some zeros. But here's the trick. You have to take one off the top and one off the bottom. I can do it again. I can do it again. But when I get to this point, I can't cancel that zero that's left because that zero doesn't have a mate on the bottom. So we have to leave that zero in there. Let's bring that zero over. So I'm just going to bring it right over here and put it right there. It's the same zero. And then 9 divided by 9 is 1. So my answer here to this division problem is 10. So what I could say is that the 9 in 96,532 is 10 times more, or 10 times greater, however you want to say it, 10 times bigger than the 9 in 59,623. it is 10 times greater. Okay. Let's look at another example. And ideally, I would have already written these out for you. But since I can't send you a book, we just have to put them down together. So I apologize for that. How does the 4 in 342 compare to the 4 in 94,652? So this time we are comparing the 4s in our two digits, or our two numbers, sorry. So I have 342. I can tell you already that that first number is smaller than this one. So I'm looking at this 4 compared to this 4. So this is a 4 in the tens spot. This is a 4 in the thousands spot. So I have 40 and I have 4,000. So let's go ahead and set up our final sentence here. The 4 in 342 is blank. We have to find this answer in just a second. Then the 4 in 94,652. And I apologize, that text message came in. I thought my phone was muted. Okay, so let's do this math and see what we can come up with here. We are comparing the 4 in 342 and the 4 in 94,652. So we need to divide. You would say the bigger number has to go on top, divided by the other number. So this time I can only cancel one set of zeros. So I can take top and bottom right there. But then I have 2 zeros left over right there. So we're going to bring those over to our answer. Just copy them over here. There they are. And then 4 divides into itself one time. So our answer is 100. 100 times smaller, because that 342 is the smaller of these two numbers. So this time, instead of bigger or more, we would say 100 times smaller. You could also say 100 times less than the 4 in the larger number. And I think just for my own sake, guys, I'm going to draw a line between my problems so I can tell where one stops and another one starts. And we have room for one more example. So let's say, as our final example, and rather than have to write out that whole sentence, let's just shorten it. Let's say compare the 7 in 7,632,526, and the 7 in 176,241. And I'm just making up numbers. You can do this with any numbers you want. So the first number is 7,632,526. And we're interested in the value of that 7 right there. And then in this one, it's 176,241. We're interested in the 7 right there. So we have this 7 compared to this 7. This 7 is 7 million. So that is a 7 with 6 zeros after it. And then we have a 7 in the 10,000 seat. So we have 70,000, 7 times 10. And we need to compare these. So we have 7 million over 70,000. And hopefully we can cancel some zeros to make this a little easier. So we have 1 set, 2 sets, 3 sets, 4 sets. So I will have to bring these 2 zeros over in my answer. We can't cancel them, so you just bring them over. And 7 into itself is 1. So this answer is also 100. And let's write our answer in the form we need to. So we would say the 7 in the first number, and I'm just going to put it that way. The 7 in the first number is 100 times. We have to decide if it's bigger or smaller. So you just look at your 2 numbers here. Let me make sure you're with me. Right here, the first number is bigger. So it is 100 times bigger than the 7 in the second number. So we are comparing place values. Okay, that brings us to the end of our lesson. We did our memory piece, we did our flashcards. I am going to underline the title of my lesson. But other than that, I think this one is done. If you have questions, please contact your instructor. And I will see you in the next video where I believe we're working on rounding. I hope you have a really good day, and I'll see you soon. Bye-bye.